Now that we know what a mole is and how to find molar mass, we're going to talk about moles within chemical reactions. So we're going to cover a concept called mole ratios. These notes only have one question, and that is dealing with what do the coefficients in the chemical equations stand for. So we've been working with chemical equations, translating, balancing, predicting products, all that fun stuff that you just love to do. Now we're going to actually talk about what those big numbers out front, those coefficients, what do they stand for when we are dealing with, measuring things out and such. If you guessed moles, golly, you're smart, because that's what we're talking about these days is moles. So those coefficients definitely are going to represent the moles of a substance that are taking part in that chemical reaction. So let's take a look at a chemical reaction and kind of see what that means. All right, so let's take a look at this chemical equation. Looks like a fun one. CaI2 plus NaC2O4 reacts to form CaC2O4 plus 2 NaI2. So like we've seen before, we have a whole bunch of these little subscripts, okay, that tells us how many atoms are in the molecule. Then we have this big number out here, okay, which is our coefficient. That's the thing that tells us the moles. So if we were to kind of translate this into molar jargon, it would look like this. 1 mole of calcium iodide. Now, because remember, if there's no number out here, it's our invisible 1. Okay, so 1 mole of calcium iodide reacts with 1 mole of sodium oxalate, that's what it's called, to produce, again, 1 mole of calcium oxalate, and we have a 2 out front here, so that means 2 moles of sodium iodide. Okay, so that's what that means. That's why the coefficients are representative of the moles. So that's how it works. So if you have 1 mole of this and 1 mole of that, it's going to react to form 1 mole of this and 2 moles of that. All right, so coefficients stand for the moles. So if the coefficients give you the number of moles of each reactant product that are taking place in the chemical reaction, that means, okay, that they also, those coefficients are going to give you the mole ratio of reactants that gives the maximum product. Okay, so when you write out a balanced chemical equation, you are telling, the person, the scientist, whoever, this is how you get the most bang for your buck. Okay, so if we take a look at this example here with sodium and chlorine to make sodium chloride, all right, this says that we need 2 moles of Na, of sodium. We got to mix that with 1 mole of chlorine gas. And what are we going to get? 2 moles of sodium chloride. Not 1, not 3, not 4, 2. Okay, so this amount of reactants is going to give the maximum amount of products. No more, no less. All right, and so when we're talking about mole ratio, okay, we can take a look and see, okay, what's the ratio between sodium and chlorine? So what's the ratio between sodium and chlorine? Well, sodium has a 2, so we have 2 moles of sodium for every 1 mole of chlorine in this reaction. Okay, pretty easy. So we always need 2 moles of sodium and 1 mole of chlorine to give us our maximum amount of product, which is 2 moles of sodium chloride. Okay. We can also take a look at like a different ratio, 2 other different things to compare. For example, what if we want to know the mole ratio between chlorine and sodium chloride? Okay. Well, we look at our equation here. We have 1 mole of chlorine in this reaction, and it makes 2 moles of NaCl, so it's a 1-to-2 ratio. All right, so the last thing that we're going to put down, and the thing that we need to keep in mind is that is this. Coefficients tell you the number of moles, not mass, or volume. Okay, so when we take a look back up here at this equation, it is not saying 2 grams of sodium and 1 gram of chlorine make 2 grams of NaCl. It's not grams. You cannot do that. You cannot assume that. It also doesn't tell you, well, if you take 2 milliliters of sodium and 2 milliliters of chlorine, it'll make 2 milliliters of NaCl. It does not tell you volume. You cannot assume that. The only thing it tells you is moles. It is saying 2 moles of Na and 1 mole of chlorine make 2 moles of sodium chloride. It's the only interpretation that you can have. Okay? Have I made myself clear? Awesome. All right, we'll see you tomorrow for a lab that has to do with mole ratios. Done.